So 5.1, modeling periodic behavior. Okay, so we're going to talk about periodic functions, which is a function that has a pattern of y values that repeats at regular intervals. Okay, so for example, over here, let's start at the top here. It's going to go big bump, medium, little, big. Okay, big, little, medium, little, big. Okay, so it's repeating at regular intervals, and it's going to take the exact same amount of time. For example, this went from like -6 all the way to like 1 almost. Actually, -5.5 maybe to 0.5. Okay, and then this is going to take all the way up until almost 7, right? So like 5.5 away from each other. 6 away from each other. Okay, so regular intervals means the exact same amount of time it takes to repeat. Okay, so we're going to talk about cycles. A cycle is one complete repetition of the pattern. Okay, so exactly what I just did, like big, small, medium, small, big. Big, small, medium, small, big. Okay, what is the period? Well, it's the horizontal length of one cycle of the graph. Okay, sometimes this is in time or a measurement. In this case, the period would be 6, right? It takes maybe 6 seconds to go through one cycle. And then amplitude. So amplitude, we're gonna get more into that. Amplitude is like half the distance between the max and the min values. So the min value here is -5, the max is 5. Okay, so we would draw a line like right in the middle, which conveniently this time is on the x-axis, and the amplitude would be 5. It goes up 5 and then down 5. And we're going to have a formula for it as well. Max minus min divided by 2. Okay, so let's examine each graph and determine whether the function is periodic. And if it is, we're going to determine the period and amplitude. Okay, so for the first one here, okay, 6 to 4, and then it's going to go down, above, and down again, and back to like kind of like where that started, which is the x-axis, and then big hump, down, up, down. I would say that yes, this is periodic. So what is the period? Well, we went from -6 all the way to 0, and then 0 again all the way to 6. So if we take a look from -6 to 0, 6, 0 to 6 is 6, the period is 6 units maybe. Okay, I don't really know what the unit is, but that's okay. And then we're going to go, what's the amplitude? Okay, so the maximum here is, let's go 1.8, and the minimum is -1.8. So the amplitude is 1.8. It goes up 1.8, and then it goes down 1.8. Okay, now the second one. So goes up to 1, goes up to 2, 1, 3, 1, 4. Okay, so this is actually not repeating, so it's not periodic. So we're not going to worry about the period or the amplitude for this one, because it's not going to be consistent, it's not going to be the same. Okay, we do see this pattern here of going up to the 1s. However, between each of those, we have something different. We have like the zigzag going up to the 2, going up to the 3, going up to the 4. So these are not the same height. That means it's not periodic. Okay, example 2. Consider the periodic function shown below, and then we're going to state the following. Okay, so it starts at -7, like that we can see on the graph. Okay, it goes, periodic functions go on forever in each direction. So on the graph, let's say it starts at -7, it goes up, down, and then repeats at -1, up, down, repeats at 5. Okay, so what's the period? Well, it's between like, how much is it from -7 to -1? Well, it's 6 units. Or from -1 to 5, again, 6 units. Okay, The amplitude, we're formally going to do max minus min and then divided by 2. Okay, so the max number here is 3, min is negative 2. So 3 minus negative 2 over 2, I get 5 over 2. So the amplitude is 2.5. Okay, all that means to me is like, if we go from the top 2.5 units down, that's going to be the middle of our graph, right, at 0.5, and then 2.5 units down. Okay, domain is going to be XER since every periodic function is going on forever, both to the left and the right. Okay, and the range, range is going to be min to max. And it's always going to be in this form because periodic functions are continuous. That means like you're not going to have like, you're going to be able to put your pencil on your paper and draw it in like one shot. You're never going to pick up your pencil. Okay, so YER such that like the minimum we said is negative 2. Okay, so Y is between negative 2 and 3. Now for the next 3, we kind of did these in the first unit. Determine f at 2. So you want to just go to the graph, locate 2. Well, our function's at 1. Okay, determine f at 5. Go to the graph, locate 5. Our function's actually at 0 there. Okay, these ones actually say predict. So we're going to predict f at 8. Here's the thing. We know that this graph repeats all the time, like forever and ever. So we want f at 8. Here's our issue. We go only up until 6. So we need it 2 steps forward than where it would have been here, okay? So we have to, like, what I would do is I would find, okay, where's the graph starting at negative 2 and then going up? Well, we could loop that back over here and we could be like, okay, so here to here, that's actually what we're looking at, right? The exact same since it's periodic. So now 5 would have been here, 6 would have also been here, this would be 7, this would be 8. We're back at 1. Okay, let's try that for negative 10. So this is going the other way. So negative 7 is right on the x-axis, and that's like going down, right? So if we go actually over here, here and here, this would actually be what is going on at negative 7 as well. That means this is what's going on at negative 8. This is also what's going on at negative 9 and negative 10. So I get 1. Okay, because it's repeating forever and ever, we can just keep looping around. So we're going to predict f at 14. So we know where it is at 6. 6 is at 2, going up. So this is 6, 7, 8, 9, 10, 11, 12. I'm going to keep looping back around. Then it's going 13, 14. So at 14, it's also acting like it does at f at 1, and it's at 3. Okay, determine 4 values such that f at x equals 2. So f at x equals 2, we know that that means just like where is y 2? Okay, so y being 2 would be anywhere here. So 2 occurs at negative 6, negative 4.5, maybe a half-ish, and then 1.5. Okay, so example 3, an airplane travels back and forth from Toronto to Vancouver. Okay, then obviously Vancouver back to Toronto. It flies for 4 hours one way, lands for an hour, probably to clean, to stock more food, okay, and then flies back. Below is the table of values for the airplane. Okay, we're going to plot the graph below for 3 plane trips and then fill in the values in the chart. So here's the thing. We're not going like there and back in the graph. We're actually going to just do time and height. Okay, so this is going to be height, this is going to be time. Okay. Oh, and we already have an x and the y-axis, so let's actually plot 0, 0. Okay, 0.5, 500. Okay, so after half an hour, the flight is 500 meters in the air. After an hour, it's 750. After 1.5 hours, it's going to be 1,000. And then at 2, it's going to be, 1,000. At 2.5, it's going to be 1,000. Okay, that makes sense because it's kind of approximately say the same altitude in the air. And then at 300, it's going to go back down, or sorry, 3 hours, 3.5 hours, and then 4.5. 3.5. Then we have 4 to 5 o'clock. It's on the ground. Okay, so if this is periodic, we're going to repeat this. Okay, so it's going up to 500, 700, 1,000, 1,000, 1,000. Sorry, 750, 500, and then back down for an hour. Okay, let's repeat it one more time. So up to in a half an hour, we're at 500, 750, an hour in the air, and then back down to 750, back down to 500, and then 1 full hour on the ground. Okay, so that's how it's going to look approximately. Now, what's the maximum height? Well, maximum height is 1,000 meters. We can see that right here. What's the minimum height? Well, it's going to be 0 meters. It's going to be exactly on the ground, right? And then what's a period? Well, we're going to go from 0 all the way to 5, right? And then 5 all the way to 10, and then 10 all the way to 15. So 1 period is going to be 5 hours. In this time, we have this in context. It's actually going to be hours. All right, 1,000 meters. And by the way, with the 1,000 and the 0, we can actually, if it asks for amplitude, we can actually solve for the amplitude, which is max minus min divided by 2. So 1,000 minus 0 over 2, which is 500 meters. So we can see that the halfway through the graph is 500 meters, and it's going to go up 500 meters to the top, 500 meters to the bottom. Okay, we're going to sketch any function that has a period of 6 and an amplitude of 3. Wow, we're really on this 6. So it's going to go from here to here, and then from here to here, and repeat, okay? And then it's going to have an amplitude of 3. So from the middle to the top is going to be 3 units, and from the middle to the bottom is also going to be 3 units. So we can pick any, like let's pick from, we're going to go from 3 to 9 then. 1, 2, 3, okay, and 6, another 6 in our lives. 6 is going to be like the middle. So let's start at 6, we'll go up 2, and then after 2, let's go down, all the way down after 2, and then back up to 6. Okay, so up 2, down all the way, outline is there, and then up 2. Okay, that would be a function, again, with period of 6, amplitude of 3.